Next up, we have another student speaker who will be briefly talking about the BioLux, which is that apparel right over there. So I'd like to welcome Sarah Szabo to come on the podium to talk about her experiences. So Sarah?
So hello everyone, my name is Sarah Szabo. I'm the lead software developer for the BioLux project, and my major is biology with a pre-med specialization. I met Professor Nagasawa during a biomedical research class working with the EEGs, although I never anticipated it going in the artistic direction, which was very fortunate that I met her, because when I was working with the prior professor, it was a pure scientific application, although Professor Nagasawa informed me that it had many artistic applications as well, and we decided to port much of the code over. So my interest would be gaming, Battlefield 4. I'm top 1% for player skill worldwide with a 4K DR. And I have many other hobbies such as physics, science fiction, and other artistic projects as well, including learning the Japanese language. So, it's nice linked. Duplicate. Okay, there we go. So this was the previous slide. So our project is BioLux, which is an EEG, which I'm wearing right now, and which is actually changing the colors there. It reads my brainwaves once per second and turns them into light. The lines of light are woven fiber optic cable, and the dress is 100% wireless with no need for AC power whatsoever. And we have the previous version of the dress, which was used in Synesthesia Playground. And it wasn't based on the EEG sensor, it was based on pulse rate, as Professor Nagasawa said earlier. And we have a short video. How do you play this?
Just gotta move the mouse.
It's extended. So you can notice every single time she's about to play the key, she has a sharp exhale, which is picked up by the sensor, and changes subsequently. There it is. So here's our full diagram. The data starts in the EEG headset, is run through a computer with a lot of code and stuff that I wrote. It does a lot of interesting analysis and sends it to a wireless module, which then broadcasts to the fiber optic projector, which then changes the light. This is a great collaboration between science and the art, and our project in particular shows the beauty of the human mind. There's been a lot of discussion about the brain this entire panel, but our project in particular displays the beauty of the human brain and is unique to every single individual. So every single light show will then be different depending on the wearer, because everybody has a different brain and they have different firing patterns, and it's a very interesting source of data from a programming standpoint. And there's this really great quote from Carl Sagan, who I'd consider one of my mentors, although unfortunately he died before I really heard about him. Imagination will often carry us to worlds that never were, but without it we go nowhere. Which is definitely true. And we can also see that in the works of Robert McCall, who was a very famous NASA painter, I would say the best. And instead of a list of physics equations which are an accurate depiction of space flight, we instead have these beautiful works, some of which are multiple stories tall. And it really shows the drama of spaceflight as well as the hard science. They kind of intermesh and go hand in hand. And more importantly, this creates a self-fulfilling prophecy between artists, engineers, and scientists, in which the scientists can make a certain level of science, but then it's the artists and the authors to go one step beyond it. And that, in turn, excites scientists. I mean, I don't know how many of us are walking around with primitive kind of tricorders in our pockets from a lot of works like that. People saw Star Trek and they were excited to make some of the technology. So our project in particular makes EEGs into light. Once per second, the EEG reads my brain scan, and it varies the intensity with certain parameters, and it varies the color with other parameters. And we use a very complicated model created by neuroscientists to actually do these. The user interface, which is this, also has certain gifts which it will change depending on if you get your brain excited enough or recessed into your own head enough, which is referred to as meditation in the literature. And it will display either action-oriented gifs or more natural, slow, kind of like stream typed gifs. And as far as the design of BioLux, we had a download from an AI researcher at Istanbul University. So it's really interesting to think that some part of our program could be being used for AI or neurology research, or both, at Istanbul University. And as far as the overall design, it was incredibly fun to make. Some of the loops operate at 30 hertz, which means it does something 30 times per second, and I can't really think of anything I do 30 times per second. And like I said earlier, it really shows the beauty of the human body and mind, and you can get a very nice artistic display from it. While researching the project and brainwaves, I feel like I had a better understanding of these systems, and generally how they relate to the human body in general. And I think that bodies are kind of fascinating, which is why I want to go into medicine. So it's really a great display of it.
So for the interest of time, we're going to show the live demo after the presentation, so you can actually try it out then.